Welcome back. We have learned what Nash equilibrium is, and we have also obtained Nash equilibrium in some simple game. In this particular video, I want to give you two basic ways of obtaining Nash equilibrium. We are using these ways, but I just want to summarize them here. The reason is very simple, that game theory is all about obtaining Nash equilibrium. This is the single most important concept in this particular course. So it is worth spending little bit more time on this solution concept. Just to recap, that definition of Nash equilibrium is simple, that Nash equilibrium is an action profile. Let us say that action profile is A star. It contains one action for each of the player, such that none of the players can become better off by changing their action unilaterally. What do I mean by changing their action unilaterally? It means while other players keep their actions unchanged, behavior of other player would be taken as the part of environment for this particular player. And mathematically we can write it in two ways. We can say this A star is a Nash equilibrium. We are writing A star differently, exactly the same thing, using deleted action profile. This is for AI, and for this is for all remaining player. So we can say UI always give player I more than or equal to any other action AI dash, while other players keep on playing A minus I star. It has to be true for all I. This has to be true for all the players. Further, this has to be true for all AI dash belonging to AI. So here you can take any action of this player. Still, this has to give at least as much as this one. And this can be translated in another way also. Rather than writing like this, we can say that A star is a Nash equilibrium. Here also we are writing again like this, A minus I star, when each of the player, so of course I am writing here for player I, each of the player is playing his best response given what other are doing. So we can say this AI star belongs to one of the best responses, and this is true for all I. So there are two ways to go about it, obtaining the Nash equilibrium. One is that propose any action profile, like let us say you have this game, you can say here is AB, here is CD. So one way to go about is to propose that A comma C, let us say, is a Nash equilibrium. And I am repeating myself, I know, but this is very, very important. If this part you have learned, at least 50% of the course is done. Most of the time we would be obtaining the Nash equilibrium. So we propose that A comma C is a Nash equilibrium, and then we have to show that given what player 2 is doing, if A changes his action to, let us say, A to B, he doesn't become better off. So the payoff associated to A comma C cannot be less than the payoff associated to B comma C for player 1. And similarly, the payoff associated with A comma C cannot be less than A comma D for player 2. So because player 2 can deviate here, player 1 can deviate here if we are talking about this. So that is one way to go about it. Check whether player can become better off by unilaterally deviating or not. The second is to take the best response route. So of course, when we say A star is the Nash equilibrium, each player should be playing their best response given what other players are doing. So what is the idea? Let us say if other players in the two-player game, we can say that here A, B, C, D, exactly the same example that we are taking. So we can obtain the best response of player 1 given the second player is playing C, and we can obtain the best response of player 1 given the other player is playing D. And similarly for other player we can obtain that best response of player 2 given that first player is playing A, and best response of player 2 given that first player is playing B. And so in this way we are obtaining best response correspondence of player 1 and we are obtaining the best response correspondence of player 2, and then we can plot. In this we can have here, let us say this is A, this is B, this is C, and this is D. Okay, and then we can mark, given player 2 is playing C, where is the best response? Let us say if this is a best response here, and here this is the best response when from player 1. And in other color we can do, let us say, for if when player 1 is playing A, the best response from player 2 is D, and here the best response is C when player 1 is playing B. So here the best responses, they overlap one another. It means when you take D, the best response from player 1 is A, and when you take A, best response from player 2 is D, and therefore A comma D would be the Nash equilibrium. These are two different ways to go about it, and these two ways we keep on using. Okay, so I hope you have understood how to obtain Nash equilibrium. In the next video we will try to understand what do we mean by a Nash equilibrium.